welcome to Pale Blue Pod, the astronomy podcast for people who are overwhelmed by the universe but still want to be its friend.
I'm Connie, and I'm the universe's curious friend.
Aw, also my friend.
Also your
Hi,
friend.
everyone. I'm Dr. Moiya McTier. I'm Connie's friend and the universe's friend, also an astrophysicist and a folklorist. But, that's just on the business card. That's not who I, am as a person,
Yeah,
you know?
Yeah, exactly.
Yeah, you do know. You know that,
I do
Connie.
know, because I feel similarly about things.
Yeah. Bestie, how close are you feeling to the universe this week?
I'm feeling only moderately close to the universe. I haven't really spent a lot of time outside. I probably need some more sun.
But you're in Florida. Don't you just have all the sun?
You would think, but where my apartment is, if I don't go outside, I get limited amounts of sun. It's sun comes through, but it's it is lovely. It's dappled, dappled sunlight through the trees.
It is.
But it's not enough for that vitamin D, so I haven't been getting my minerals from the universe.
Got it. Okay, well, maybe next week.
Yeah,
hopefully,
I'm working on it.
Some more vitamins. Nice. I've been feeling pretty close to the universe this week. I've been having some late nights, and I've been really taking some moments to be mindful and reflect and just get in tune, I think, with my environment. It's been really nice this last week having some time, because I was sick, so I had some time to just really sit with the universe, and I took that opportunity. It was nice.
Amazing. I'm happy for you.
Thank you. Yeah, I started thinking about how old the universe really is. I like to do that sometimes. Just think about the vastness of 14 billion years, and think about how even the longest lived stars and the stars that will live the longest, we've never seen them die. We don't actually know what's going to happen. We just have models about M-type stars reaching the next phase of their life cycle. So I spent some time thinking about that.
Oh.
Your face, bestie.
Oh. Wow. Yeah. Yeah, when we say this podcast is for people who are overwhelmed by the universe but want to be its friend, I am overwhelmed by what she just said, and I'm still her friend. So here we are. How did that make you feel? Thinking about the age of the universe really makes me, I don't know, actually what it is, it feels like, the THX audio company that would do that sound at the beginning of movies that went
yes.
That's what that felt like to me.
That is so
just
specific.
Oh no. Grand, but scary but epic.
Cool.
Yeah.
Is there anything I can do to make it feel less scary?
I mean, we're working on it.
And more towards just grand. Okay.
That's why I'm here.
Great.
I'm working on it episode by episode. I hope everyone's joining me on this journey.
Yeah, I think today's episode probably won't help you with the time scale of the universe, but it might help you feel a bit better about the size of things in space. So today we're talking about the Gaia mission, the Gaia spacecraft, and the map of the Milky Way galaxy that it made. Its claim to fame is that it has produced the most accurate and precise map of the Milky Way galaxy to date.
Mm-hmm. And see, when you say things like that, I'm just like, how? It's just it's like the text is really large in my head. But how? And I know you're going to tell me because that's why I'm here. But also, it's just, and as I'm saying this, I already feel like I'm back in the 1600s where it's the Earth feels so grand that how could we put it on a map, right? How could we put it on a 2D dimensional map as people are exploring the world? And it's did it feel that way? For them trying to map out the Earth. Now we've mapped out Earth and we're going to space and it's just infinitely bigger. So how do you put that? And I know it can't be a 2-dimensional map, although that would be, I really wish it could. But and then the 3-dimensional, and then
we do have. Yes, I understand. I remember early on in my classes just really trying to understand the three-dimensional nature of space.
I think that's one of the places where that one astrophysics class that I took for about 2 weeks, I think that's probably one of the places. The other place was all the math that I had to do. So I'm glad I know you now.
We'll ignore
and you
the
can
math.
do the math. Yeah, you can talk about the math.
Yeah. Bestie, how good is your spatial imagination? Like, if you close your eyes, can you picture yourself in different spaces?
Yes.
Okay.
So, like, if I close my eyes, I can picture myself in a different room. Is that like where you mean?
Yeah.
Yeah.
And can you picture yourself within that room moving around and shifting your orientation and perspective?
Well, yes, but also a lot of times my imagination, like when I'm recollecting or imagining myself in a place, like I imagined myself in a different room in my apartment just now, and it was in the third person.
Oh.
Like it was from a exterior point of view, but also a little bit interior. Like it kind of flips. I don't know what that is about, but.
I think you play a lot of video games that like split screen, third person, first person view is baked in. Okay, interesting.
Yeah, but I can picture myself looking around.
Good. I think that skill is the same that I use when I am kind of zipping around in the galaxy or the universe in the mental map of it that I have. And that skill is really helpful with switching reference frames. In astronomy, there's a lot of reference frames. Are you establishing a coordinate system where the solar system is at the center, or one where the center of the galaxy, the supermassive black hole, is at the center, or something even larger?
Yeah.
And is it a stationary coordinate system, or is it moving with something? Like, we have to think about this a lot in astronomy. And so you have the skill. And over time, if you can also just learn more about how space is distributed and what the shape of it is, then maybe you can practice also moving around in that mental galaxy map.
Yeah.
But today's episode is all about galaxy maps and how we made a really nice one.
Ooh, okay, great.
Awesome. As I will like to do, with you as a new co-host, I would love to start with the questions you have. So today we're talking about Gaia. What do you want to know?
Yeah. So I look at our agenda and you put, the little topic at the top for me so that I know what it is. And then I just go from there and I guess. And so I was like, okay, I get the idea of the spacecraft is going to map the universe. And then, but that is really where I start with questions. Like, what does that exactly mean? Space, again, infinite and ever growing. So how do you map? How much of space have we mapped now? How much is left? And then is there just like an exponential like bar above the number that's just like, and then into infinity? To infinity.
Yeah, that's a great question. And it's hard to say that we've mapped like X% of the universe.
Okay.
It's really more about how in depth are we at each scale. So we have the largest volume that we've mapped of the universe is with the Sloan Digital Sky Survey, and that didn't get very granular. It's not mapping even like individual galaxies at that point. Like, well, I guess it does have some galaxies, but it's definitely not mapping like individual stars and solar systems.
Okay.
So it's really like broad view, and its volume is something like 600 cubic light years. It's quite large. But then we also say that the biggest map of the universe was just produced by the Cosmos Web mission, and that used the JWST, the Jelly Welly Space Telly,
right,
to peer deep into the universe, but not all around. The Sloan Digital Sky Survey was about getting the volume in different directions. James Webb was about peering into the one direction and maybe moving around a little bit, but still a smaller section of the sky. And we say that it's the biggest map of the universe because it has the most galaxies in it. It's 800,000 galaxies in this smaller region of the sky, and that's like a deep map. So we have a lot of it mapped, but not all in detail.
Right.
Gaia mapped about 1% of the stars in the galaxy.
Wow.
Yes, over 1 billion stars. And 1% is quite a feat for us.
I bet. Did they like start at the Milky Way? Like, did they start here and then expand out? Or did they like pick a different area that we're less familiar with?
Which survey? All of them in general, or?
Yeah, like, if you know, but Gaia in particular.
Gaia in particular, yeah. So it's all just mapping the stuff in the Milky Way galaxy.
Okay.
And it orbits around the sun with the Earth. So it sees, and it can like scan up and down, and it can also spin. So as it's spinning and as it's orbiting the sun with us, it sees basically most of the sky. Wow. And it sees far enough to get a good view of things within our own galaxy, but not distant galaxies.
Okay. And then when you say like see far enough, how is that data being collected into the spacecraft? Because the way you described it, I was like, okay, I can see that like somewhere along our orbital path around the sun. Cool. I was like, whoa, that's very interesting. Love that. And then you're like, oh, it can turn and spin. And so I'm imagining cameras, but then I'm like, how does a camera capture? Yeah, I think that's it. How does a camera capture space in space?
Okay. I have a whole section about the kind of schematics of the spacecraft later. Do you want to get into that now, or do you want to start your other questions?
No, we can go to my other questions because I'm excited to get to that part. Okay.
Awesome.
So next is, can we see, like a civilian, like a layperson, like someone who doesn't really know sciencey things, can we see what has been mapped so far somewhere? I know there are a lot of public records that, NASA and other science folks put out. But would I understand it? Like, is it something that is viewable in a way that like I'm imagining I have an app called like Skyview, and you can like, see the stars and see what stars you're looking at or which constellations. And so I'm imagining like being able to like look at the universe and move a little screen or a toggle. Like, does that exist?
Specifically for Gaia data?
For Gaia data.
There is a visualization program. It's a website that you can go to. Connie, I put it in the notes if you want to click on it.
Thank you.
Yes. So for everyone else, we will post this somewhere on our socials, but it was developed by a scientist to visualize archived Gaia data. The data is publicly available. Anyone can download it because it's a survey mission. So that means individual astronomers didn't request observations on it. Before it even launched, it was planned exactly what it would look at and when and how. And it did that from 2014 to 2025, and then it was retired. That was the end. So all of the data, as it becomes available after it's processed and cleaned and everything, is open to whoever wants to download it. But I can personally attest that downloading that file sucks.
Yeah, I would imagine so. I imagine that's a pretty big file, or maybe
it's a big file, and it's documentation. If you aren't used to combing through astronomy data sets, it's going to have so many rows of data that are specific to astronomy things, and it's not well documented in my experience. One of the moments I think I realized in grad school that I definitely was not supposed to be a research astronomer was when the second data set from Gaia was released. There was a hackathon session. It happened in like April of 2018, and a bunch of astronomers in New York City gathered at the Center for Computational Astrophysics in the Flatiron, and we waited. No, actually, at that point, we didn't have to wait to download the data because it's a European instrument, so it was already out by the time the East Coasters woke up, and people were downloading the data. I couldn't even figure out how to get it from the website. That's how much I was struggling. So my advisor had to give me a flash drive with the data on it. And then I didn't know what to do with it. And it was so stressful. And I left that building in tears because I just didn't feel like I was doing this thing that I should be able to do. Yeah. Everyone else was doing it. People were like already publishing. People published papers that week about.
They had to be the first, you know?
Stuff from
just
Gaia.
like,
yeah.
And then they're just typing,
just typing away. And I was like, still trying to just type my name. I felt, you know, those nightmares where you're at a standardized test and you can't answer anything, like you can't even write your name. That's how I felt at the Gaia DR2 hackathon. So you can download the data, but I wouldn't recommend it. Nor would I recommend this visualization service.
I opened the website and I'm already like, what year is this from? And then I'm like, okay, science and data, there's certain things where it's like, if it's just trying to be simple, it has like old looks. But then I still just don't really get what I'm looking at. I've taken a screenshot. I will share it. And we'll put you could put the website in the show notes, I guess. But yeah, there is a pretty graph that looks like it's like the Milky Way. I can see the sun in the center with all the concentration around the plane and the what are you? I feel like you called it something once. That like hump over when you're looking at the Milky Way.
Bulge.
The bulge.
Yes.
Yeah.
In the center.
Yeah.
Or the one that goes kind of over all of it.
Over all of it. So
okay. The big circle around everything is the dark matter halo, but Gaia is an optical instrument, so it should just be stars that you're seeing and other bright objects. So I imagine it's just like the glow halo stars, and so you can't. There is some like an app if people want to try it out. More power to you.
Noted.
Yeah. Any other questions?
Not right now.
Okay, cool. Then I want to start with its history. How did it come to be? And then we'll get into the schematics so we can figure out how it works.
Okay, thank you.
So first of all, this is not a NASA mission. I think most of the observatories and telescopes that I've covered on the pod so far have been NASA stuff. This is operated by the European Space Agency, which is, like it's multinational collaboration. It was proposed in October of 1993 by Michael Perryman, who is a European Space Agency scientist, and Lennart Lindegren, who was a Swedish scientist working at Lund Observatory at Lund University in Sweden. And it was meant to be a follow-up to the Hipparcos mission, which was another ESA survey that operated from 1989 to 1993. And it cataloged 100,000 stars and like mapped their positions and velocities. And everyone was so excited. Like they were like, oh my God, 100,000 stars. And as soon as the mission was up, there were scientists being like, I bet we can do better. And then they started planning Gaia.
Scientists are very, very competitive, I think, right?
Yeah, we are. Especially astro people, I think. But I don't know. I don't think we're competitive in a way that's as jerky as physicists. Sorry, physicists.
Okay, noted.
Yeah.
Noted.
So it had to go through many proposal rounds, and it was accepted by the European Space Agency's Science Program Committee in October of 2000. This is 7 years after it was initially imagined by those two scientists. And then the next phase of approval after a first round of development and research into how feasible it would be, that happened in February of 2006. So that's when they really started developing and building it for real. The initial name was an acronym. It stood for the Global Astrometric Interferometer for Astrophysics.
Interferometer?
Yes, I knew that would be a new word. An interferometer is a device where you get multiple telescopes working together as one. This is most common in radio astronomy when you have the really long wavelengths of light and you need huge telescopes to observe it properly. It's difficult to just make a 300-meter telescope, especially if you want to move it around. So instead, we'll have like 20 5-meter telescopes working together to make a giant thing.
So you can make one
Yes.
picture. Okay.
Yes.
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 Yes. I feel like I have heard about this with the very inch of space photography I've looked into, because photography is one of my hobbies. But in space photography, it always looks really cool, but I haven't really sat down to look into how people, even from like, ground level, even just like pictures of the sky and stuff. And I know it's a lot of, holding still and compositions of photos together. I've seen some of that before.
Yeah, because it works by having the wave patterns from all of these telescopes that interfere with each other. You measure how they interfere. So you're measuring the interference pattern. So it's an interferometer.
Okay.
Well, that was the original plan. They wanted to have an optical interferometer up in space, and that changed. That's really difficult. We're only now really starting to get an optical interferometer in space going with a laser interferometer up there. We'll see if it works out, but. They did want to keep the name. So even though they changed it from being an interferometer, they just kept it Gaia for like a continuity.
Love that. Continuity with...
Well, it had been called Gaia for many years.
Just the continuity of that. Oh, okay. I thought it was with the other mission, the one before it. And I was like, is the other one a Greek Titan?
No, Hipparchus is the name of an ancient Greek astronomer and mathematician who developed the magnitude system, which is what we use to determine how bright stars are.
Oh.
And because it was a mission that measured stellar positions and brightnesses, they honored Hipparchus. Would you like to guess how much it cost to build Gaia, this spacecraft, and launch it into space?
In what year?
Great question. It launched in December of 2013. Okay. It took 26 days to travel about 1 million miles to reach its resting place beyond the moon, and it stays there, locked in that configuration at a place called Lagrange Point 2. It's also where JWST is. The Lagrange points there are a couple of them, and they are places in space where gravity kind of balances out. So the gravitational influence of I guess in that line, the moon and the Earth and the sun will keep anything in that spot kind of without it needing to expend much fuel to stay put.
Okay. And is that how it stays put? Like is it that they find a spot in the orbit and then it just kind of stays in the orbit?
Well, that's what Lagrange points are. They are special places where gravity is balanced. So they're like stable bubbles where if you get something in a Lagrange point, it will move in that bubble with the other things that are in that same gravity special place.
Gotcha.
That's Is gravity special place okay?
Yeah.
Okay, cool.
I'll take it. Because now I'm realizing that I don't actually know how like other telescopes and things stay up above the Earth, like in satellites. Like I check for lights. I don't know.
They usually have to use fuel, or they're caught up in some other gravity special spot. There are a bunch of them. Not all Lagrange points.
Sure.
Lagrange points are special because they are stable and they will move with our orbit. But the other ones are probably just like in constant free fall, especially the satellites that are near us. And they will probably use fuel to just like keep them accelerating or keep them moving.
Okay.
So it's out there, and it was launched in 2013, started working in like 2014, and was deactivated early in 2025 in like January or March. Couldn't find an exact date.
Right. And you were asking how much it costs to like build it and launch it? Well, numbers are the opposite of my thing, but I'm going to take a stab. Even guessing like financials, I'm like 35 million euros. But like somewhere around 35 million dollars. Let's go with dollars.
It's 750 million euros, about $1 billion.
Wow. That does make, yeah, that makes sense.
Mm-hmm. Yeah, it was pretty expensive because it's fancy. It is a very precise instrument tuned to be able to do the same thing, basically, as measuring the diameter of a human hair from 1,000 kilometers away.
Oh.
So it sees really small differences between things and can measure precise motions. It is an astrometry mission. It's a mission meaning that other people can't request time on it. So it's planned exactly what the telescope's going to do. And astrometry is the measurement of positions in space. Like specific position in space. And so what Gaia measures is precise positions and three-dimensional velocities. It also measures a spectra of the star, so it gives a rough measurement of how much of different types of elements are present in the star. It gives a measure of the temperature of the star, the color of the star in different band passes. It gives the surface gravity of the star, and I think it can also estimate ages based on the spectral information. And it does all of that for 2 billion stars, plus several million other types of objects like brown dwarfs and quasars and pulsars and things like that.
So you said it was pointed at particular things and that it's like they know how many stars. Is it just because like they were like here, this section and this section and this section, and then there's that many stars in each one?
Yes, it's not pointing at individual stars, but it is. It's like doing a sweep of the sky.
So it's like these are the ones in this area, basically.
Yeah. The initial plan was for it to last 5 years, and over those 5 years, do 70 observations of all of its 2 billion targets. It then was extended beyond 5 years in 2018 by another 7 years. So it just continued to take more observations of the same stuff.
Oh, so they did complete the 70 observations in the amount of time? Because I was wondering if that's why they had to extend it, because they needed to like do additional, like they needed to catch up basically, but they were able to just do more.
Yeah, they did their plan and then some, because these telescopes last longer than our initial plans account for, which is a good thing. So we get extra science out of them. And we got about 7 extra years of science out of Gaia.
Wow. It's like a microscope for space is what it feels like. But a microscope doesn't even tell you as much, right?
That's just a telescope. A telescope is a microscope.
I know, but... Dang it, it is.
Hello, it's me. Connie is playing with my office microscope as we speak, so let me share some messages with you. The first message is a thank you to all of my patrons. We are an independent podcast, so it'd be really hard to make Pale Blue Pod without you. And for your support, I am eternally grateful. Thank you so much. I want to give a special shout out to my Sun-like stars, Scott Reynolds, Tom T, Nicole Bartlett, Ashley Shambo, Mark Mahoney, and... welcome to our new Sun-like star, Bruce Sedloff. I'm so happy to see you in the sky, Bruce. You are joining a golden group of friends here. Thank you all so much. If you are listening and you want to join this awesome group of people and support an indie podcast, hear your name on the show, make it onto the patron star chart, and get research notes for most episodes, you can do that at patreon.com/palebluepod for $5 a month. You can also make a one-time donation as a supernova at the PayPal link in the episode description. And of course, if you can't support the show financially, we understand. We still love you because you are space. There's actually a great way to help the show grow that doesn't cost you anything except maybe some phone data. I'm not sure what plan you have, but if you could take a link to this episode and send it to someone who you think would be really interested in mapping space or the history of different types of telescopes, please do. And Connie and I would really appreciate that. Thank you in advance. My next message is a new podcast alert from Multitude. We have joining us a new show called American Medieval. This is a podcast about the Middle Ages, but with an American twist. Every week, Professor Matthew Gabriel is joined by an expert scholar to talk about either some bit of the medieval world itself or how Americans have, throughout our history, used the Middle Ages to say something about ourselves. If America has never been fully modern, it might be because we've always been a little bit medieval. So check out AmericanMedieval.com for more. And in case you're one of those people like me who's always had trouble spelling medieval the first time around, that link is also in the show's description. New episodes are available every Wednesday. You can look for them wherever you get your podcasts. And they just did an episode on medieval eels. I haven't listened to it yet, but I know I need to. And you need to know more about medieval eels. So check out American Medieval wherever you get your podcasts. All right, Connie has seen all the tiny things that the office has to offer, so let's get back to talking about Gaia. It's a Swiss Army knife. All of our telescopes are Swiss Army knives. So the way it does all of that measuring is through two different telescopes, like essentially two different mirrors and cameras, and three different instruments. So the two telescopes are identical. They are pointing about 106 degrees away from each other. That's so you get this wide field of view. And each of the mirrors is about 1.5 meters tall and about half a meter across. So they're not circular mirrors. And both of them will focus light to the same place. And then that light goes down into a very complicated CCD array. CCDs are charged coupled devices, which is an array of pixels that you would find in one of your cameras. Have you heard of CCDs before?
No.
Well, your cameras work because of stuff that astronomers develop, so you're welcome.
Thank you. Yes.
So the light goes down into a very fancy array of pixels. There are more than 1 billion pixels. It's a gigapixel. Whoa. And it is specially
only 24
tuned.
Still. Megapixels.
Well, if you had a 750 million euro, maybe you could afford a gigapixel.
Yeah. Working on it.
And send it to space. You're working on it one day if we get enough patrons.
Yeah. Please follow us and love us. Thank you.
So it's those two telescopes that then funnel the light through the CCD into these different instruments. One instrument is an astrometer. It's an astrometry instrument, which just precisely measures the positions of these stars. It does that with a method called parallax. Have you heard of parallax?
I feel like I have, but I don't remember why. But also I think it's stuck with me because I like interesting words with, a double L and an X.
Yeah, it's a good one.
Yeah.
Parallax is the phenomenon of an object that you're observing seeming to shift position when your perspective shifts. So if you were to put out your thumb at arm's length and close one of your eyes, see where your thumb is, and then switch to the other eye.
Right. Yeah.
And notice how your thumb appears to move. It's not that it's actually moving. It's that the angle from which you are viewing the object changes as you switch from eye to eye. Now, with our eyes, the difference is maybe a couple of inches. In space, what we do, because again, this object is orbiting with us, we have to use the distance between one side of the sun and the other side of the sun. So over the course of 6 months, you get that difference in perspective. And when you're on opposite sides of the sun, when you look at the same star, it will appear to be in different positions, just like your thumb does. And if you measure how much it shifts, you can measure how far away it is. Because if you do the same thing with your thumb, but it's much closer, the shift is bigger. There's an equation that we have that tells us, based on the angle between the apparent positions of the distant object, that we can measure how far away it is. So the astrometer is precisely measuring where it looks like things are in the sky. And then 6 months later, we can do this calculation to figure out how far away it is, which gives us that third dimension of distance. And we can do that over many years. and get a precise value for these distances. So that's just one instrument that's giving us position.
Okay.
It's giving us position, which gives us velocity in two different directions. It gives us velocity up and down, because if the position moves over time, up and down, also velocity side to side. So it gives us position and then two types of velocity. It gives us 3 dimensions of position with the parallax, and then 2 out of 3 dimensions of velocity. To get the third dimension of velocity, which would be towards and away from the observer. Right? We call that radial velocity. To get that, you need the second type of instrument, which is a spectrometer.
Okay.
This takes the light from the stars and splits it up into the different wavelengths and measures how much energy you get at all of those different wavelengths. If the star is moving towards and away from us, its light gets red shifted and blue shifted.
I have heard of that.
Yeah. So you can measure how much the spectrum shifts from blue to red, and that difference, there's another equation you can use to figure out that velocity, radial velocity towards and away from us. So that gives you the third velocity dimension.
Oh.
And then the spectrometer is how we know the chemical composition of the star. That also, through models, gives us an idea of the age of the star.
How does it know the composition?
Because it tells us how much energy is at the different wavelengths of light. When there's an element in the star, that wavelength of light is absorbed, so it appears as a dark spot in the spectrum, and we've mapped the different elements to their specific wavelengths.
Right. So when I'm looking when I'm looking at space photography, of planets, from NASA on Instagram, that's where I'd be finding them. Is that where they determine the color that they present? Venus is usually this orange, yellow, burning sun looking color. It's from the light spectrum, but it's really telling us.
Well,
or
that's
are they just
a planet
deciding a color
versus stars.
Right.
But the reason we color those planets the way we do is because we have an idea of what elements are in their atmosphere, and we do have that information through spectrometry.
Okay.
Yeah.
Bringing it all together.
Yeah. So the spectral data, it gives us the chemical composition and also the temperature of the star, and then the temperature and the chemical composition of the star can be plugged into models that then tell you the age of the star. The third instrument, it's actually 2 instruments of the same kind. There are 2 photometers. Photometers measure how much light you get from something. So this gives us the brightness, which I think also can tell us the temperature of the star.
Right. Okay.
There's a red one that's tuned to redder colors and a blue one that's tuned to bluer colors, but it's all optical. So it operates between about 300 nanometers and about 1,000 nanometers. And so with all of that, you get position, velocity, brightness, and then all the extra stuff. But Gaia was really meant to give those parameters, the position, the velocity, and the distance, to a star, because we wanted to map the galaxy.
Right.
So it did that. It's now completed its mission. It was deactivated in early 2025, but not all of the data has been processed yet.
I wouldn't think so.
Right.
But how fast does it come in? Is that something that you would know? It's coming from
regularly.
It's just daily downloads of what it's seeing live?
I don't know about daily, but it does regularly downlink, at least weekly, I'd say.
Okay.
But often
and then they
enough,
all comb through that.
They have to remove all of the outliers. They have to remove any sort of systematic biases that the machine has. They have to put it into a form that other scientists can actually use, like a data file of all of the numbers instead of just raw pixel data. And so that takes time. It has had 3 different data releases at this point. The 4th and final data release is expected in December of 2026. And
that does make sense to me.
Yes, it takes a while. That data release will finally have the full astrometry information. Because the astrometry is so precise, you need to observe for a really long time to bring your error bars down.
Yeah, because you'd have more data to compare. Margins of error.
Yes. So we observe it multiple times, so they just haven't released that data yet. With all of the astrometry data, they expect to be able to find tens of thousands of new exoplanets through astrometry.
Your favorite thing?
My favorite thing. That's why I'm bringing it up first. Because to date, we have found fewer than 10 planets through astrometry. That's how hard it is to measure these tiny little distances. And Gaia is going to be precise enough.
Because they're not as hot as stars, so they're not as loud or bright.
We are not looking at the actual planets themselves. We are looking at the stars being tugged by the planet moving around them. This is the same thing as radial velocity. When we use radial velocity to find planets, we're looking for the stars wobble through.
Wobble, baby, wobble, baby, wobble, baby, wobble.
We are looking for how the star is being tugged by the planet's gravity. And we look at the spectrum of the star and we see it red shifting and blue shifting. And that tells us how much the star is moving, which tells us the mass of the planet involved. But that is only possible if the planet is passing between us and the star. That's not going to be most planet orientations out in space because things aren't all neatly lined up for us to view. So there will be many more planets that, from our perspective, if we could see them, look like the star in the middle and then, the planet doing a full donut around it so that it never passes in front of the star from our point of view. We would need astrometry in that case to see the stars wobble going up and down and side to side instead of towards and away from us. But because of the methods used, there's like a fun math derivation that I got to do in grad school to show why this is the case. But when you're using radial velocity, it is just a lot easier to see the signal than with the astrometry.
Gotcha. Well, sort of. It's like I hear you and I'm processing, but I'm going to need a couple more listens to really process, but I'm with you.
Cool.
And then you were adorable because you said an awesome
got
mathematical...
to do a really fun derivation.
A really fun derivation. And
it's
just
because
words I've never spoken in my entire life. So I'm observing, I'm joining some new... worlds today.
I think it's because the way that you translate the astrometry method adds in an extra distance factor that it's divided by, so the signal is smaller for astrometry. And it was fun to do that out. Okay, I'm done.
Yay.
I'm done now. I did promise no math. I'm so sorry. So that was
Listen, I'll allow it. It made you really happy.
Thank you. So that's a future discovery goal for Gaia. But it has discovered many cool things even before the fourth data release. It has discovered hundreds of thousands of asteroids and comets in our own solar system. That is not an exaggeration. That's so many.
That's a lot.
Yes. It's found a bunch of brown dwarfs, which are kind of between planets and stars in terms of mass, and they're doing their own special type of fusion that's not hydrogen into helium. It's very interesting, the brown dwarfs. It found a bunch of exploding stars, so many supernovae, and was looking at hundreds of thousands of quasars, trying to find these active, energetic black holes in other galaxies. Along with the map of the galaxy, like that goes into the map of the galaxy. So that's very exciting. Then there are just some science things that it has discovered that are consequences of now us having this great map. We were able to more accurately measure the mass of the Milky Way, which is surprisingly difficult to do, but we got the error bars down a little bit.
Nice.
And it's a little bit more massive than we used to think it was. As is the Large Magellanic Cloud, which is a small satellite galaxy about 10 to 20% the mass of the Milky Way. And I think we used to think that it was just maybe max 10% the mass of the Milky Way. And look at that. It's growing. We are actively stealing its gas, and we're going to eat it and, absorb it into our Milky Way body in a few billion years. But for now, you go, Large Magellanic Cloud. We also discovered why the disk of the Milky Way is not shaped like a perfect CD. Instead, it's like if Salvador Dali painted a CD. It's warped a little bit so that there are like dips and I guess it's like if you see a record spinning in slow motion and it looks kind of wobbly.
Yeah.
That's what the disk of the Milky Way is doing. And we were perplexed. We were like, why isn't this just flat and stable? It's because we think about maybe a few billion years ago, or maybe a billion years ago, another small satellite galaxy called Sagittarius started to merge or like fell into the Milky Way. And now it's this stream of stars that have been stretched out. And that gravitational interaction caused our disk to do this weird warping thing. And the Sagittarius stream has passed up and down through the disk several times. Each time it does, there's this burst of new star formation. And we think that our sun may have formed during one such pass-throughs about 4.5 billion years ago.
Wow. See, that you start using the B word, and I'm just like,
I did.
My brain it becomes a big bubble. I don't know how else to describe it. It's just like a section, just like bubbles up. It's like, it's trying to absorb the concept of a billion years ago. Like, I can't.
See, this is how you know billionaires aren't ethical.
Yeah. Yeah, because I've seen the rice videos. I've seen the rice videos where one little thing, and then they'd show you the million, and it's like, wow, a million's a lot. That's a lot of rice. And then they show you a billion, and it's like, why is that bigger than his whole body?
Right.
So when you think about, okay, a million years ago, like, I'm getting there in terms of, like, space scale. I'm working on it. But then my brain loses all sense of anything after that.
Yeah, it is a lot to think about. These things happening billions of years ago and interrupting systems that are hundreds of thousands of light years across. It is a lot.
And then putting it into a computer and trying to like learn more about it.
Yeah.
Incredible.
Eventually you do just get used to it.
Yeah.
To the numbers once you hear them enough. Yeah.
Okay. It's on only my third day out here, so I'm getting there.
We also learned, in addition to the disk not being a perfectly flat disk, that the Milky Way itself, when you consider its entire dark matter halo and the cloud of stuff around us, that is not spherically symmetrical like we expected it to be. Instead, they said, this is not even my comparison, they said it's shaped like a rugby ball that has just been kicked. So there is some sort of preferential direction here, almost as if we're like moving so fast through a medium that there's this kind of bow shock in front of us, which is interesting.
What is that?
I don't know. Well, what is a bow shock?
Yeah.
Oh, you know, in anime when someone punches something really hard and there's that like comet of air around their fist?
Yeah. Yeah.
That's a bow shock.
Bestie, I'm so proud of you for using an anime reference. I am so proud of you. Wow. Good job.
Thank you. It's when something is moving through.
But now I'm imagining the Earth is a fist. And I'm just like,
well, no, it's our entire galaxy
the Milky Way
is a fist.
Yeah, the Milky Way is a fist.
Yes, the galaxy just
punching through the void.
Yeah, you said it, not me. So it's innocent.
Okay.
Okay. Yeah, and I don't really know why it's not spherically symmetrical, but Gaia did figure out that it's not. I do have a silly game. I don't know if it's even worth playing, but...
Okay, let's see.
Okay, don't scroll down.
I'm down.
Okay. This game is called Which Gaia Did It? And you have to tell me if this thing that I say is about the goddess, the primordial personification of the earth from Greek mythology, the telescope, or a human named Gaia.
Okay, so just like a random person.
Yeah.
Okay.
This first one. Personally committed to maintaining a healthy Earth climate and caring about how it affects the people living on Earth.
Gaia, a person.
This is a human named Gaia. Her name is Gaia Vince, and she wrote a book called Nomad Century, all about how climate change is forcing mass migration because it is making parts of the world uninhabitable. So
yeah.
thank you,
Good job,
Gaia Vince. Yeah. And good job, Connie. Next one.
Yeah.
This Gaia advised Hercules to travel to the underworld to retrieve the Stone of Forgetfulness.
That one's just really, really so difficult for me. I don't actually know that story, so I have to read more about Hercules' many labors. But I'm going to say Gaia the Titaness. She a Titan or a god? I think she's a Titan, right?
Well, she gave birth to the Titans.
Yeah, she's the mama Titan. She's
one of the protogenoi, one of the primordial beings, but like a god.
Yes. Yeah.
This is a human named Gaia Germans, who's an actress in a movie from 1961 called Hercules in the Haunted World, where she played Medea, and Hercules came to her and asked what he should do to get back at Hera or something.
Were you so excited when you saw this? Like, did you Google Gaia people and then, or like Gaia Wikipedia? Like, you just search Gaia on Wikipedia and it has the disambiguation.
No, the disambiguation was not helpful. I did Google Gaia. I Googled people named Gaia. I did once meet Gaia Vince at a book event. So she was the inspo for this game. Because I was I know one person named Gaia. I can find others.
Absolutely.
So thank you, Gaia Germans, for that. Maybe we could watch Hercules in the Haunted World sometime, Connie. Okay. This next one. Once married to Ouranos the Sky, but now separated and maintaining her own complex systems.
You know, the look of mischief that I see on your face really tells me that it's not the obvious one, which would be Titan the goddess, but I'm gonna I don't know, because we didn't go over that there was a companion. Like, if there was a companion telescope, I'd be like, it was Gaia the telescope, and maybe you just didn't tell me about it. So that's my strongest guess, but I'm gonna go with another person named Gaia.
It's the telescope.
Knowing your mischief, I was like, this must be somehow the telescope.
That's because
your little face doing the little face stuff, but also the irony and like your love of personifying things in space, which I also love about you. I mean, I grew up on Sailor Moon. Like, my whole identity is literally just the personification of space and not the actual space stuff. So I was like, I have a feeling.
So this is a bit of a cheat, I think, because I was like, when Gaia, the spacecraft, launched through the atmosphere, that was like her being married to Ouranos the Sky, because Ouranos is canonically the personification of our atmosphere. So they were once married, but they are now separated, and Gaia is outside the atmosphere, like firmly separated from Ouranos, and maintaining what I think is a very complex system with those fancy CCDs.
It was the complex system. That was the second hint. It was your face and the complex systems. I could hear the italics. I could hear the quoting. And I was like, I bet the three different instruments, but one instrument is actually two instruments. I bet that's a complex system.
Yes.
Okay.
All right. Yay. I tricked you. Next one.
You did. You did.
This Gaia convinced her sons to pick a fight with her grandsons over a territorial dispute.
Okay, I'm going with Gaia the Titan.
Final answer?
Yes.
Ding, ding, ding.
Okay, yeah, I was like...
Yes, that is the...
Is there possibly a way?
This is the Gigantes
is there
War.
A dictator? Is there like a political leader somewhere whose name was Gaia? Like a treasury secretary in Greece somewhere? I don't know. I was like, there are possibilities here.
I went looking.
I was just like, let me stick to the tried and true story here.
Yes. This is the story of the Gigantes War, where after the Titanomachy, when the Olympians defeated the Titans and then imprisoned them deep inside Tartarus, which is in some stories like deep actually inside Gaia's belly, she was in a lot of pain and she didn't like that. So she got her other sons, the giants, to fight against the Olympian gods, and the giants were defeated also.
Yeah, go figure.
Go figure. So yeah, that is the Titaness Gaia. Good job. And we have one more.
Okay, I'm ready for all your shenanigans.
This Gaia was used as a pawn in a plot to kill Hercules, which was orchestrated by his brother Iphicles.
Is there another actress named Gaia? Is it the same Gaia as earlier? Gaia the person is going to be my answer. Maybe she's done another movie, or there's somehow been another Gaia who also did a Hercules movie.
This is Gaia Weiss, who was in the 2014 movie Legend of Hercules, where she plays Hebe, who is in Greek mythology the goddess of youth and beauty.
Hera's daughter.
Yes. And so they spear some things a little bit in this movie, but Hercules is being raised by a different family and not told that he's the son of Zeus. So he has this adopted brother Iphicles, and Hercules, who's like going by a different name, and Hebe are getting it on, but Iphicles wants Hebe, so he orchestrates this pretend killing of Hercules, and it's a whole drama thing.
Of course. Huh.
So there were indeed, there were more Gaias. There were more human Gaias that I could have found.
I believe it. But also it shows you that fan fiction has just been around for a long, long time. Yes. Because what do you mean he has a brother in another universe?
I think he was going by something like Isocles. It was always like Isocles and Iphicles. And
that's too close together.
I agree. Maybe it was icicles. Maybe it was icicles and Iphicles. That's how they said it. If it were like a comedy, like a period parody, that's what it would be.
Yeah, absolutely. There are so many Gaias. Thank you for having the game. It was great. Awesome. I learned so much. I learned that if your name is Gaia and you become an actress, it might just be inevitable for you to do a movie about Hercules.
I think you might have to.
Yeah.
Contractually.
Yeah, they put it on your birth certificate when they sign your name.
They won't let you into the Screen Actors Guild if you haven't completed
that's
It's
the thing
a very
that gets you in
specific
finally.
Condition.
It's the thing that finally gets you in. It's like you've been working really hard and your name is Gaia and you're like, I know that it, like, at some point this will happen for me. And then they give it to you and you're just like, wow, I can't believe it. I'm in a Hercules movie. My name is Gaia. Just, so many generations of...
So many generations of Gaias before me have foretold this to be true.
The Oracle was right.
Oh my God, I love this. But do you have any lingering questions or thoughts about Gaia the telescope?
I don't think I do. I learned so many new words today. I really thought really hard about things in space and references and, positioning and how things move in space, things go up and down and also back and forth. And so measuring that is really difficult, which I would have thought. And then you told me, and my brain is still a little wrinkly about it. But
wrinkly is good for
some
brains.
New things.
That's what you want.
Yeah. Just like that feeling of just like, and it's like, yes, it's the learning happening, which I love. But also I'm just like, okay, I'm going to go lay down now.
Brain too full.
Brain too full.
Okay, sounds good. You and your wrinkly brain can go rest.
Isn't that the way that's the way you process information? So I'm really just ready to process this new knowledge. I'm totally going to get a normal amount of sleep. I don't have problems with that.
Right. Not at all.
Not at all.
And if you do stay up, then it's just more time to get acquainted with the universe.
Exactly.
Yeah. Listeners, no matter what the oracles have predicted for you, you are space. Bye.
Bye.
Pale Blue Pod is hosted by Dr. Moiya McTier and Connie Gibbs. Moiya created the show with the funny and talented Corinne Caputo, with help from the Multitude Productions team. Our theme music is by Evan Johnston, our cover art by Shay McMullen, and our audio editing is handled by the superlative Misha Stanton. Stay in touch with us and the universe by following Pale Blue Pod on Instagram or check out our website, palebluepod.com. I, Moiya, am Go Astro Mo on all socials. If you want to support our show, join our community at patreon.com/palebluepod or send this episode to your family and friends group chats. And we're a member of Multitude, an independent podcast collective and production studio. If you like Pale Blue Pod, you will love the other shows that live on our website at multitude.productions. Thanks for listening to Pale Blue Pod. We'll be back next week.